All right, guys, this is assignment D. We're talking about the period and or speed of a rotating object, rotating around a central object. Basically, planning around the sun or star or whatever. So here we go. Here, I got my pen color changed to a purple or chartreuse or whatever you want to call it. So we're looking at a Galilean moon, Io, orbits Jupiter. Galileo, meaning Galileo saw this guy. And the distance is 4.22 times 10 to the 5th kilometers. All right. The orbital period is 1.77 Earth days. Oh, this is going to be fun. And then we need to use this data to calculate the mass of Jupiter. So let's look at the equation we're going to use. So when we use this is the period, orbital period, 2 pi. Okay. That's the how far we go around the sun, and then we got the square root of 2 radius cubed over g, gravitational constant, times mass. And this is going to be the mass of the planet or the central, whoops, I can't write, central object. So this is what's in the center of the orbit, and we're talking about near circular orbits, and basically all our planets do a near circular orbit, and all the moons are near circular. So what we need to do is we need to make sure R is in meters, mass is in kilograms, T is in seconds. 1.77 Earth days. So let's 1.77 Earth days. So, one day is how many hours? Oh, we're going to assume 24 hours, right? We're not taking account of leap years or anything else. Then we're going to multiply, for every hour we have 3,600 seconds. We need to convert these to seconds, guys. So 1.77 days, 24 hours in a day, 3,600 in a second. So we do all the multiplication. 1.77 times 24 times, if I can use the calculator correctly, we're going to have 152,928 seconds. If you want to use all these numbers, that's fine. If you want to use 1.53 times 10 to the 5th, that's fine too. The error in the uncertainty in the calculation is just going to be in this third digit. If you want to use 4, that's fine. Or you want to use the whole thing. So we got that converted into seconds. Do we need to do any other conversions? No, it looks like everything is. Oh, we need to convert to meters. So 4.22 times 10 to the 5th kilometers gets converted to 4.22 times 10 to the 8th. And let me double check my math. Times 10 to the 5th, yep. So now I'm going to take this equation and rearrange it for mass. So T is equal to 2 pi times the square root of R cubed over G times M. All right, so we got everything. We're looking for this guy, the mass. First thing you need to do before you do any other calculations is square everything, because we don't want this in the period in our equation. So square everything first. So raise everything to the power of 2. So now we have t squared is equal to 4 pi squared times r to the cube over g times m. All right, now I want mass. Multiply both sides by mass, so t squared times mass is equal to 4 pi squared times r cubed over g, and then divide both sides by t squared. So our mass is equal to 4 pi, come on pen, r cubed over t squared times that gravitational constant. Now let's put the numbers in. I'm going to go to the next slide so we have a little bit more room. So our mass, I don't know why this is not working well. Okay, here we go. How to change a function on the pen. Mass is equal to 4 pi. Now r is that big number, and if we go back here, is 4.22 times 10 to the 8th. 4.22 times 10 to the 8th. And we're going to cube this. Now g is 6.617 times 10 to the minus 11th times, and we need t squared in seconds. So that's 152 to 928. And we'll go square it. So the mass that we're looking for. And what I'm going to do is I'm going to solve for the top first. 4 times, whoops, and I forgot. And good thing I remembered this. We forgot to square that. Pi squared times the quantity 4.22 raised, might as well do it how you guys do it, raised to the third. And the top is, we're dealing with pretty huge numbers, folks. 2.967 times 10 to the 27th. And then we're going to take these two numbers and do the math. 6.617 raised to the negative 11 times 152, 928 squared. And the bottom is 1.548. So we get 2.967 times raised to the 27th divided by 1.548, and the mass of the planet is 1.92 times 10 to the 27 kilograms. And that is the answer we're looking for. If you have any questions, let me know. Thank you. This is the end of the lecture.